Hi everyone, Miss Andronicus here, and today we are comparing distributions. To compare distributions relies on us comparing two or more data sets. You can do that in a number of ways, on a number of different types of graphs or tables, for example. One way is using frequency polygons. They are used to compare frequency distributions for grouped continuous data. Points are plotted at the midpoints for each class and at the height for each frequency. And of course, when you're setting up a frequency polygon, the axes and the graph itself all need to be labeled and follow the same rules as for regular frequency diagrams. Here is an example to put that all in one place for you. So for the heights shown in the table, here is our grouped continuous data. Okay, so that's our grouped data there. It's continuous because, of course, it's between anyone from 0 centimeters less than or equal to 10 centimeters, for example. Okay, so there's the frequency there. Frequency diagram is A, frequency polygon is B. So the biggest differences that you can see is that with a frequency diagram, it's very much like a bar chart, except you can see there are no spaces between the bars, okay? This also indicates the continuous data, the continuous grouped data, because everything from 0 to 10, and including 10, has the frequency of 3. So this is our frequency diagram, which translates to this frequency polygon, as you can see over here. Frequency polygon, the smaller the grid that you're working with, the more accurate you can be. And you'll often see these smaller squares utilized for frequency polygons. You'll notice that little crosses are used because, again, we're plotting points, and when we do that in graphing, we want to make sure that we are as accurate as possible. And you'll notice that these depict the same data. So where it is a bar in a frequency diagram, the middle of the bar is chosen, the midpoint of that data, as I mentioned before, and that is where you put the point for that frequency polygon for that particular piece of data. Then it is joined in straight lines, perfectly straight lines, never curved, to the next point, to the next point, to the next point. You'll notice that it never touches, in this example, it doesn't touch the axes. It's not impossible. It can. You'll see some that do, but in this example, it doesn't. Okay? Two distributions may be used on the same axes in case you need it and to compare your distribution, but you need to use different colors and, of course, a key. So the hours worked here, you can see that in these hospitals, there are multiple hospitals. That's what's been depicted there. Administrators, physicians, and nurses have all been compared the hours that they work in hospitals. So clearly, the administrators have been working for less hours in the week. The physicians have been working for sort of in the middle, more hours, and then the nurses have worked the most hours in all these hospitals. And you can compare these distributions and draw conclusions, of course, on that data. Another type of graph or chart that is used to compare distributions are bar charts. These can be used, of course, to show two or more sets of data. There's dual bar charts or multiple bar charts. You require multiple colors and a key, otherwise the rules are the same as when you draw an ordinary bar chart. So let's have a quick look at an example. We've got the attendance of boys and girls as recorded at this club. Show it in a bar chart. So you can see it there where you've got the frequency and the day across the bottom. You've got boys and girls in the two different colors. Please note the day or that axis is labeled right in the middle of the bars, and the bars are drawn around that point. Okay, so for Monday, you've got the boys and the girls. There's always a space at the start and in the middle of the data. Never a space between the bars to show that these bars are together. This is for the boys, this is for the girls for Monday. Okay, so you can clearly see and compare the data across the week for the boys and for the girls and their attendance at a club. So you can see that girls are more likely to go evenly throughout the week. Boys are more likely to go, let's say, at the start or the middle of the week. Okay, so let's move down to this example. We have got the hours worked per week by staff in hospitals. This is actually the same example as the frequency polygon that I showed you above. This one, though, you can see is the bar chart version. So it looks very, very different. You can clearly see administrators are here working less hours. You've got the physicians in the middle and the nurses at the end. Okay, so you can see those peaks slightly differently. And I just wanted to show you this side by side, those two graphs to be able to compare. Okay, frequency polygon, these polygons do connect to the axis because that actually then forms a shape, a polygon. Okay, it has multiple sides. So that's why it is even called that. Okay, just so that you are aware and that you can see those trends and those peaks. I think personally, this is obviously a little bit more simplified because you've just got these points. You don't have the entire bar, but obviously either way, they compare trends. So just finally, when comparing, you need to draw conclusions about the data, find patterns and trends, and really understand what the data is telling you. So consider the scenario, consider the axes, the name of the axes, consider the title, etc. Consider what is being graphed and if the graph is showing data that's as expected. Because for data like this, for example, you might have a question that says, well, why do you think nurses have greater hours than administrators? Provide reasons for this. So you need to consider why that could be the case. Can you rely on this data being accurate in all scenarios? So you need to be thinking about, is this something that can be applied throughout the world or always, or is this perhaps an anomaly in the data or something that is unusual, so that you can mention that when you speak about your data analysis. Okay, have a go. Thanks, guys.